Okay, now this week's lab, we're going to do the hardness test, and we're going to show you 3 methods of checking hardness. The first method is very common in a machine shop. It's called the Rockwell hardness tester. And the Rockwell has 2 scales. One is a B scale for softer material, and then we have a C scale. The way this works, there will be a penetrator, and this is our little penetrator. This is called a diamond braille, little diamond tip. It's not a diamond like you would jewelry type. This is an industrial diamond. It's harder than our workpiece. So what's going to happen, and this is called a destructive test, it's going to actually pierce the surface of the material and it'll give us a number. We're on the C scale, which means the load that we're going to apply to this is 150 kilograms. Initial load will be around 10 kilograms. So I have 3 different samples here, and they're 3 different diameters. I have a little key. These are heat treatable materials, drill rod. And this one is a 3/4 inch diameter. And if I look over here, 3/4 inch diameter is a water hardening. The next one is 5/8, and the 5/8 is an oil hardening. And then we have air hardening. Now we're going to talk more about this in a future lab about how to harden these. Now we're going to measure the hardness of this part before heat treating. We need to have a number before we heat treat so we know if we did a good job or not. This one is the water hardening, and I'll put it in, and like I said, the anvil here, it has 2 round rollers. That way our round part won't roll off the anvil. And I'm going to come up against my diamond braille, and I'm going to bring these 2 needles to the set point on top. The long needle is going to go around a couple times, and the short one's coming up there now. So this is our set point. We have approximately 10 kilograms of load on our part, so we have a starting position. When I push this silver bar, 150 kilograms of load is going to drop down, pushing my penetrator deeper into the workpiece. So I'll push that down now. You can see it goes around a couple times maybe. This is automatic, so it'll unload itself. And we're using the C scale because we have the diamond braille in 150 kilograms. Looking at the C scale, it looks like the black around the top is about a 9, 9.5. So the units would be RC, Rockwell C scale, 9 or 9.5. Very simple to test with the Rockwell machine. Okay, we just finished the Rockwell test. Now we're going to do a Brinell test. A Brinell test is for softer material, like aluminum. Could be some plastics, a lot of different things that are softer where the Rockwell would go too deep. On the Brinell test, we have the same type of a anvil, a surface that we're going to mount our part. This has a 10 millimeter diameter ball that's going to be our penetrator instead of the diamond cone. And this ball will be forced into the workpiece. Now, a little bit about the machine. The load we're going to use for this particular example is 1,500. So what we have, if you look at this right here, we have 2 of these, one on either side. And according to our scale here, those are 250 kilograms apiece. So right now we have 500. Now this is a bigger one. We have one of these bigger ones on both sides. They're equal to 500 kilograms each. So 500 plus 500 is 1,000, another 500, so we have 1,500 kilograms. That's going to be our load that's going to be applied to the part. So what I do is I bring my workpiece up, and I just make contact with that ball. On the Rockwell test, we had to actually put a preload on it. This one will not have a preload. We just bring it up till it touches. This has a hydraulic pump, so I tighten up the valve and I start pumping. And this is going to lift up. There's a silver tape here. I want to lift it up till I get just past the silver tape. So I'm going, and we're coming up here. Okay, so we're past the silver tape. Now the load itself is pushing down on the ball. And you can see on our scale here, we're just over 1,500 kilograms, but maybe close to 1,600, somewhere in that area. This load is actually pushing down on that ball, on that little penetrator, and it's making an impression on our workpiece. And when it gets down here about 1200 or so, that means this load is dropped off. It's no longer doing anything. So I can release my pressure and take my workpiece out. Right here is where we just made that impression. Okay, now a little bit about that. Here's our 10 millimeter diameter ball, that's our D, and that made an impression on our aluminum part, our D1. This is the formula that you're going to use. So you'll have the diameter of the ball and then the impression diameter, and all that will be placed into this formula, and it'll come up with a BHN, Brinell hardness. Now that we've made our little impression on the Brinell hardness tester, we need to accurately measure that impression. To measure the impression, we can come over to a microscope here, and I'll put my part inside the microscope and I'll focus it. So I'm focusing on my little impression. And inside the microscope, there's a hash mark in the vertical and one in the horizontal plane. So what I'm doing is bringing one of those hash marks to the very edge of my impression there. So I'll look through here and bring it over there. Then I'll record the number on my micrometer here. It says a micrometer head. And let's say that's 250.250 inches. Then I will continue to look through the microscope and move it till I get to the other side of my impression. Again, looking at the hash marks inside the lens. And maybe I went to 500 now. So it started out at 0.250. When I got all the way across, it went to 0.50. I need to take the difference of those two to get our diameter of our impression. 250, then we had the 500 minus 250, so we have approximately 0.250 impression. Now you're going to use that number to plug into the formula we talked about a little bit ago. The difference is, this is reading in English units, and we need to convert to the metric, to the millimeters. So don't forget to convert before you actually take your measurement. Okay, finally we have what's called a micro hardness test. This micro hardness test is still a destructive test. It's going to make a part, a little notch or a mark on your part. Most of the time, especially bearing surfaces, you can't have any scratches. So these destructive tests, that's what they're doing, is they're putting a little impression. However, this is going to put the least amount of mark on it. We're only going to run a 200 gram, instead of kilogram, 200 grams of force. So we will still have an indenter that's going to go into our workpiece, but it's going to be such a slight amount, you will not be able to see that indentation with the naked eye. I have a part already loaded in here. What I would do is I would bring this up until it just touches, or until it focuses, so I'm focusing it. Once I have it focused, I'll push the start button. And it's going to go over here, and here's our indenter. This indenter is going to come down on the workpiece, and it's about a 20 or 25 second dwell time. Once it reaches the 200 grams of force, it'll sit there for about 20 seconds. Then it will come back out of the part, anytime now. And once it does, this is going to go back to the original microscope lens. I want to go to a higher powered, so I'm just going to push the arrows here until I get over. Now I will look through the lens and refocus, and inside that lens you'll see a little triangle. Okay, the triangle is what we're actually going to measure, and to measure that we're going to take you over to the whiteboard and I'll show you what we need to do. Okay, now unfortunately we can't show you everything on the microscope. Everything is looking through a lens and we can't videotape that. But what you're going to do is, number one, you're going to start with the low power like we did. We focus our part at low power. That gets everything lined up. Then inside the little lens there's two lines. One has 3 lines going horizontally, and you have these 2 vertical lines. What you do is you line this first one up with the center of your workpiece. And then number 3, you take the second line and you bring it and line it up perfect there. Once you get those two lines lined up, on the lens, there's a reset button. We're gonna reset it to 0. Okay, once everything's lined up, we set it to 0, we go press start. That's when we had to dwell on our impression. Once that's done, we go back to the high power lens, refocus on the high power lens. And like I said, there's a little diamond inside there. This impression is it's not visible by the naked eye. We see that diamond. So we bring this set of lines over to the very edge, just like you see here. Now the other one, we move over to the opposite edge. Once you get it there, then you press read on your microscope and it'll come up with a number, but we're not done yet. Now we have to rotate our lens 90 degrees. The eyepiece will be rotated 90 degrees, and we're going to bring that one down to the bottom and the other one to the top, and you'll hit read again. This will get us an HV number, hardness Vickers. It could be something like 178.5. That's an example, and that number has come up pretty often on our test. So the indentation is very, very, very small. You will not see it with the naked eye, but we can see it under high-powered magnification, and this is how they measure it. They just move these lines over, and it automatically calculates that number for you. So it's a direct readout, much like the Rockwell test, hardness Vickers, 178.5.